Okay, so transforming random variables. In the last few lessons, we've learned about discrete and continuous random variables and how we display this information. So now we're going to talk about changing or transforming the random variables. Now, recall from Unit 1, we had a few transformations that we applied to our data sets, and this had some impact on our information. So whether we add, subtract, or multiply by a constant, we learned that the shape remains the same. Shape is unchanged. And I'm just going to shorthand here. Shape, unchanged, same thing here. So shape is preserved regardless of which operation we're doing. Oh, I totally thought that was purple. Sorry, y'all, I'm recording early in the morning. All good. Now, when we add or subtract, our center changes. So the center being the mean or the median, and the spread is unchanged. Whereas when we multiply, both center and spread, these will both change. So just a little recall from Unit 1. And that's just because we're taking the data set and we're moving it, or we're taking this data set and we're expanding it out. So it just depends on which type of operation. And similarly, division is the same thing as multiplication by a reciprocal. So we're not going to bother too much on that right there. So let's look at an example. So again, this is just a video lesson, a quick recap. In my classroom, we'll be doing a few NIMSY activities to help us do some inquiry around this. So unfortunately can't film those, but alas, if you come here because you're my student or because you just stumbled upon this channel, I'll be walking through some of the calculator steps and whatnot. So here we go. Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. Define X as the number of passengers on a randomly selected day. Pete charges $150 per passenger. The random variable C describes the amount Pete collects on a randomly selected day, and it costs Pete $100 per trip to buy permits, gas, and a ferry pass. The random variable V describes the profit Pete makes on a randomly selected day. And we know that the standard deviation of X is as follows, 1.090. So here's our distribution. The probability of having 2 passengers on a randomly selected day is 0.15, and the same logic follows for the rest of this distribution. So let's find the mean for X. Again, we need to communicate what we're doing. You can use the expectation or mu of X. So this is what I'm looking for. Since I'm looking for the expectation, that means I'm going to sum the product of each observation and its respective probability. And what that looks like in context for this distribution is as follows. So notice here it just says find the mean, not interpret the mean. The verbs do matter. So I've got this here. And when I do this, I obtain the result, 3.75. And that's just a number. This number means nothing without context. So here, that 3.75 is going to be passengers. So again, what are we doing? What does it mean? What does it look like? What does it equal? And then, of course, our context point there of passengers. Not just 3.75, what? Elephants, cookies, sticks of dynamite, etc. Got to have context. And if we were to interpret this, we would say something along the lines of, in the long run average, we expect the number of passengers to be about 3.75. Something like that. Now, the standard deviation is already provided to us. I will say it's more common on the AP exam to find the mean and to interpret the standard deviation. You may be asked to find the standard deviation from the random variable, and just as a reminder, that formula looks like this. It is the sum of the squared differences from the mean times their respective probabilities. And we can also use this to do our interpretation. So since we're looking at the difference from the observations and the mean, we know that in the long run average, in the long run average, the number of passengers differs from the mean by about, and then here it's going to be 1.090 passengers. So we differ from the mean number of passengers by about 1.090 passengers. So just some quick interpretations and findings there. Okay, so let's continue on. Well, that was just our standard random variable. That was our discrete random variable. So now what we have going on is that we were told to find the probability distribution for C. Well, in the example, it told us that it cost $150 per passenger. So this 150x here, what's going to happen is that I will, sorry y'all, it's because I'm also running the calculator here currently, because I'm just so excited, typing in a few things, but of course I'm going to model this out because I'm a great teacher. Whew, okay, so here we have the cost is equal to 150 times x. Well, recall from the previous distribution that our x's were at least, at a minimum, 2 passengers up to 6 passengers. So this was our x values here. So in order to find the new values, the probabilities aren't changing, just what we're measuring. So for 2 passengers, it would cost $300. For 3 passengers, it would cost $450. And you get the idea here. We're just multiplying the number of passengers by the cost per passenger. Now again, to find the expectation of C, we're going to take the sum of the probabilities and we're going to multiply them by, the sum of the product of the outcomes and their probabilities. Now again, we can shorthand our work here. So I'm going to do 300 times 0.15 plus 450 times 0.25, and this is what I mean when we shorthand. Usually when there's more than like 3 or 4, you just take the first 2 and then take the last one. So this communicates to the reader that you at least are understanding the pattern here. And that's going to give us some value. Same thing for the standard deviation of C. That's going to be the sum of the products of the squared differences times their probabilities. So again, it's going to look like 300 minus some number here squared times 0.15, and here I am definitely going to shorthand and find this value here. Okay, so how could I find this value? Again, I could multiply this out and I would obtain the result of 562, and I cannot write this early in the morning. Still working on my green tea, but here we go, 562.50. And so that number is going to go here, 562.5, 562.5, etc., and that'll give us some other value. Okay, so I'm actually going to teach you now how to do this in the calculator. It's not always needed. Usually on the AP exam, the FRQs are only about 3 or 4, so you can do them by hand, but it is always helpful. We have tools, so might as well use them. So notice in L1, and the way I did this was I went to, I hit the stat key here. I went to edit, and then in L1, I typed in my x values, and in L2, I typed in my probabilities, and notice how they match. So 2 is 0.15, 3 is etc., blah, 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 blah. Well, in L3 here, I'm actually going to rewrite this list. So I'm going to take 150, type that in, times, and then since I want the product of 150 and these values, that's the list in L1, I'm going to go to second L1 here, and notice now I'm able to type in this keystroke. Well, 150 times L1 produces the following results, the ones that we filled in here. So in order to find the summary statistics, now we're going to go to second quit, and I wish I could zoom out on this camera here. We are going to go to stat, we're going to select calc, and we're going to select one variable, statistics. Now our list is what we are looking at. So for here, the x values on our list, that was in L3, so again, second L3, second 3. And the frequency is in which they occur, right? Our relative frequencies, our probabilities. Well, I typed that into L2. So this is going to find the statistics between those values. And notice x bar here, what should we use mu of x because we assume this is the population. X bar, 562.50. Then I go down here to sigma, it actually finds the value for me. So I'm going to look here, and that's about 163.46. Yep, so I've got the values here, so I'm going to box these up. And notice that even though it's not asking for an interpretation, it's still important to include context. So here, since the expectation and the standard deviation are dealing with monetary values, notice that I'm putting in a $ sign for these parameters here.